Hello and welcome to lecture series on electrodynamics. Today we are going to discuss fundamental theorem of curl. It states that the integral of del cross V dot dA over a surface is equal to integral V dot dl. It's also called the Stokes' theorem. So what it says, we know that curl del cross V is curl, and curl measure the twist in the function, and we know that high curl is when we have whirlpool. So if we put paddle wheel into the whirlpool, we can see that it start rotating. So integral of the rotation over the surface means, in fact, we are trying to measure the total. The right side is saying total curl or rotation of function v added over some region, over some surface, over some surface. So that's the right side. So it's equal to the function value over the line, which covered that surface area around the line, close line. Say we have a surface, this surface, and there is a function v, and the one way we can calculate the total rotation of this v is taking the curl at every small point here. So here we have to take del cross v and then take nth point del cross v over the surface and integrate over the whole surface. So that's the right side. Other way we can do is just going around the line and check the value of the v and add all the values of v, and that will also measure the total rotation of the surface, total rotation of the vector v. So there is ambiguity usually comes with the direction of the dot product. So dot product we have, if we are using this counterclockwise direction, so we are going this way, and the thumb, you can again say just like a right hand rule, the thumb is pointing outward, and if this is YZ, so say the direction of the outward normal is on the X direction, positive X direction. So we'll take the dot product, or the area D is positive, and the thumb is pointing downward. If we go the go in the clockwise direction, so the thumb is pointing inward. So we'll take the area as a negative sign. So we will decide the sign positive when we go counterclockwise. over the line, and negative when we go clockwise. All right, so if we see on the right side that we have del cross v dot dA. Again, we can relate this with the fundamental theorem of calculus that we have a line and then we have endpoints, the two endpoints. Now here we have a surface. So what is the endpoint of a surface? The endpoint of a surface is a line. So here we need to integrate over a line. So it's a closed line. Now, if we check the right side, it says the integral area integral is on the surface. So it seems that surface matters. But if we see on the left side, right side, then we have only the endpoints. So in fact, this integral del cross v dot dA is only depend on the boundary of the surface. So it is independent of the shape of the surface. Any surface is fine as long as we are going to integrate. Just we need only the endpoints of the surface. So there is a corollary, and it says integral del cross v dot dA depends only on the boundary line. Not on particular surface. And extension to this corollary, we can also see that if we have a closed loop integration on the right side, if we have a closed surface, then the boundaries, the line joining each other will be the initial lines and the final lines will be the same. So the right side will become 0. So closed loop integral of divergence, closed loop surface integral of a curl of any function v is 0. So we can check these ideas use with an example. We have example 1.11. We are given a function v and v2x plus 3y square y plus 4yz and we are asked to check Stokes' theorem over a square surface, and the square surface is given it's a unit square 1 x y z. So we have to prove the Stokes' theorem. So Stokes' theorem is del cross V dot dA is equal to integral V dot dA. So first we have to take left side. For left side, we have to resolve del cross V. So for del cross V, we will use the determinant method. So we have x, y, z, and partial over partial x, partial over partial y, partial over partial z, and 0 2xz plus 3y square 4yz square. So it will become x into y is minus z. So it will become 4z square minus 2x minus y so we have to take this minus this 0 minus 0 plus z, then we have to take this minus this, so it will become 2z minus 0. So this will turn out to be 4z square minus 2x x plus 2z z. So now we have to decide the direction of dA. So direction of dA, if we go the counterclockwise this way on the loop, then the thumb is pointing outward the area, we will take the outward, then we have to take positive dy dz x unit vector. We are using counterclockwise direction. So del cross V dot dA will become 4z square minus 2x dy dz, and the square is located at x is equal to 0. So we have to plug in the x value, then it will turn out 4z square dy dz. And the limits for integration is for x and for y and z is 0 and 1. So del cross V dot dA is equal to integral 0 to 1 4z square dy dz. So dy will return 1, dz will become 4z cube divided by 3, 0 to 1, and the whole thing will become 4 by 3. So integral on the left side is 4 by 3. Now we have to resolve the right side. So we have to take the value of v over the line and close line. So we have 4. We can divide the whole integral into 4 parts. So this is 1, 2, 3, and 4. So 1 is on y-axis from 0 to 1, and 2 is from 0 to 1 with z with y is equal to 1 here. So for 1, we can say 1 plus 2 plus 3 plus 4. So if we resolve 1, so we have the function value dotted with dl. So what will be dl for this case? Dl is equal to is y is varying from 0 to 1, and then z is 0, x is 0. So dl is dy and y positive. We are moving in positive y direction. All right, so we have to take v dot dl. V dot dl will become the y component. Oh, the y component in this case is two xz plus 3 y square. Let me check. I plug in the correct value of v. This is, yeah, y component. All right, so it will become dy. We have z is equal to 0, x is equal to 0. So this term will disappear. So we have 3y square dy. And taking the integral on both sides, so it will become 3y square dy integrated over 0 to 1. So y cubed by 3, 0 to 1 is equal to 1. So first integral turned out to be 1. Now let's try the second one. Y is equal to 1, x is equal to 0, and z is going from 0 to 1. So dl is dz, z unit vector, and v dot dl is equal to 4yz square dz. As y is equal to 1, so it turned out to be 4z square dz. And taking it the integral again, v dot dl will become 4z square integrated 0 to 1 dz, and it turned out to be 4 by 3. So third one is 1 is less than y is less than 0, and then we have z is equal to 1, x is equal to 0. So taking v dot dl integral, so it will become 3y square integral 1 to 0 dy, and if we integrate it, it will return -1. So the last one, the fourth one is x is equal to 0, y is equal to 0, and z is going from -1 to 0. So v dot dl will become 4yz, and it will turn out dz is equal to 0 as y is equal to 0. So the whole integral fourth v dot dl will become 0, the fourth one. So we have to add all to have, so 1 plus 4 by 3 minus 1 plus 0 is equal to 4 by 3. So we have the same number del cross v dot dA is equal to 4 by 3. Hence the Stokes's theorem is proved.